In this lesson, we are gonna go over a specific numerical integration method known as the trapezoidal rule. The trapezoidal rule allows you to estimate the value of a definite integral which represents the area under a curve. So let's say we have a curve y is equal to x square and we wish to estimate the area under a curve from 0 to 10. Use the trapezoidal rule to do so. So it's graph this function. So this is the right side of y equals x square. And so we want to calculate and estimate the area of the shaded region. Now let's use 5 subinterval and 5 rectangles to do so. And then we can confirm how close our estimation is using the exact value of the definite integral. So first we need to calculate delta x, the width of each subintervals, and that's going to be b minus a divided by n. So we are going from 0 to 10. In this case, b is 10 and a is 0 and is 5. So the interval is from 0 to 10 divided by 5 is 2. So delta x is 2. Now what I like to do is create a number line from a to b, in this case 0 to 10, and delta x is 2. So the width of each subinterval it's going to be 2. Now, just to recap, using the left endpoint for a Riemann sum problem, you would have to choose 5 points out of 6 points listed. Since n is equal to 5, there's 5 intervals, and you would have to choose 5 of the 6 points. So, the left endpoint rule, you would use 0, 2, 4, 6, and 8. Now, if you wish to do a Riemann sum problem using the 8 endpoints, you have to use this 5 out of 6 endpoints. So one of the point they are not all endpoints. So you are always gonna use 5 out of 6 points if you are using the left endpoints rule or the right endpoint rule or the midpoint rule. So using the right endpoint rule, it's gonna be 2, 4, 6, 8, 10. And now if you are employing the midpoint rule, you would simply pick the points in the middle like 1, 3, 5, 7, and 9. For the trapezoidal rule, you should use all 6 points. You are not gonna use 5 out of 6 players. You are gonna use all of them. And so that's how the trapezoidal rule differs in one way from using the left endpoint, the right endpoint, or the midpoint rule. Now, what is the formula for the trapezoidal rule? The area of the rectangles will be equal to delta x divided by 2. These are sum of the area of the rectangles times f of x0 plus 2 times f of x1 plus 2 times f of x2, and then it's going to continue. The second to last one will be 2f of x and minus 1, and the last one will be just f of x n. So here is we need to know for the trapezoidal rule. The first one and the last one, these are y value. Do not multiply those by 2. All of the y value in the middle and multiply those by 2. That 2 times half will give you 1. Now let's finish this example to t sub n where n is 5. We are gonna have t sub 5 that's equal to delta x over 2, and this example delta x we said with 10 minus 0 divided by 5. Now point x of x0 and x1, those are the points that we had on the number line. The first x value was 0
and then it went up by 2 because delta x is 2. So the next one is gonna be f of 2, but we need to multiply that by 2 and then 2 times of 4 plus 2 times of 6 and 2 times of 8, but the very last one we are not going to multiply by 2. So the f of 10 is last one. So keep that in the mind. The first and the last one do not multiply by 2. So never multiply this 2y value by 2, but middle ones you need to do so. So 2 divided by 2 is 1, and keep in mind f of x is x square in this problem. So f of 0, that's going to be 0 square. So that's 0, and then f of 2. 2 square is 4. 4 square is 16. 6 square is 36. 8 square is 64. And 10 square is 100. And don't divide that by 2. Now 2 times 8, 4 is 8. 2 times 60 is 32. 2 times 36 is 72. 2 times 64 is 128. Then plus 100. Now 8 plus 32, that's 40. 72 plus 128, that's 200. And 200 plus 100, 300 plus 40. This will give us 340. So that's the approximate area under the curve. So now it's calculate the exact answer by evaluate the definite integral. So expect answer is going to be the integral from a to b 0 to 10 x square dx. The antiderivative of x square is x cubed divided by 3 evaluated from 0 to 10. So if we plug in 10, it's going to be 10 to the third over 3. And then if we plug in 0, that's gonna gonna be 0. 10 times is the 1000. So we have 1000 divided by 3. So the exact answer is 333.3 repeating, and so this represents the area under the curve. As we see in this example, the trapezoidal rule did a very good job in approximating the exact answer of the area under the curve. 340 is very close to 33.3, and so the trapezoidal rule is a very good approximation. If you wish to evaluate the definite integral or find the area under the curve, let's work on this world problem. The table below show the rate at which water flow through a pipe into a storage tank. This rate is measured by 10 minutes. Estimate the amount of water that will accumulate in the first hour using a trapezoidal rule. So we have one of those accumulation problem. The amount that will be accumulates is equal to the definite integral of the water flow rate as a function of t dt. Now we don't have a function for RIT, so we have to estimate this value using the trapezoidal rule, and we have a total of 7 points, and so we have 6 interval. So this is going to be t sub 6. So n is 6 in this example on the interval 0 to 16. So if we calculate delta x, it's going to be b minus a divided by n. So that's 60 minutes 0 divided by 6. And so we can see that delta x is 10 minutes. So now using the trapezoidal rule, it's going to be delta x divided by 2 times the first point f of 0, and then plus 2 times f of 10 plus 2 times f of 20 all the way to f of 15, and the last one we are not going to multiply it by 2. It's just going to be f of 60. 10 divided by 2 is 5. F of 0 based on a table is 3.8 gallons per minute. Now, if you multiply the minutes because it was 10 minutes divided by 2 times the gallons per minute, you are going to get the amount of water that accumulates into the tank and the unit of gallons. Now this is going to be 2 times of 10, so at 10 the rate is 4.5, and then for f of 20 the rate is 6.2, and then at 30 the rate is 7, and at 40 the rate is 7.5, at 50 it's 6.9, and then at 60 it's simply 6.2. We are not going to multiply that by 2. Now 2 times 4.5 is 9, 2 times 6.2 is 12.4, 2 times 7 is 14, 2 times 7.5 is 15, 2 times 6.9 that's going to be 13.8, and then plus 6.2. So you can type this into a calculator if you want to, and this will give you 371, and unit will be in gallons. So that is the amount of water that will accumulate in the tank based on trapezoidal rule. So this is just an estimate. The exact answer might be different from this, but this one, but it's going to be close to it.